All right. You have now collected a map of a large piece of the radio sky using Skynet. We're talking 300 to 400 or more square degrees. So a good chunk of the sky, about 1% of the sky in a single map. So in this video, I'm going to remind you how to turn that into an image. We've done this before with little tiny maps centered on bright sources. Now we're going to do it for this large map, and there are a few differences and a few pitfalls. Okay, so you go to Skynet. Right now, I'm at my observatory, radio observing, and it's showing me my observations, the observations that I placed. But maybe you didn't place this observation. Maybe a teammate did. So let me show you how to search for other maps if they observed in the same group as you, the same Skynet time account. Then you can click on Group Observation, type in a name, or if you want to search the entire collaboration across all institutions, you can click on Collaboration Observations. That's what I'm going to do right now. And I'm looking for map 68. Now, if they used a different name, you won't find it this way. Sometimes people will include a space between map and in this case 68. So that's something else you can try. This is why it's important to keep your observation log up to date. If when they put the observation in, they entered it in the observation log, you can just go there and see what it's called. But I'm going to search on map 68 and you can see a number of them have been taken. I'm going to select this one. Now, the first thing you want to do is preview it with the preliminary data products. Start by coming down here and looking at the path map, and it looks super clean. Looks really good. Nice, clean turnarounds. Then I look at the images here. They look good. Both channels look good. There's a bright source here. There's some separation, so there is a time delay. The data will need to be time shift corrected a fair amount to make this map work, but that should be doable. And it doesn't look like there's anything else in the map, but once we process it with Radio Cartographer, all sorts of stuff will come out. Here is the light curve, and we can see that bright source, some bright stuff near the end of the map. And most importantly, here's the spectrum. And we're looking for RFI. We want to cut the RFI out of our map so we make a nice clean map. There's a little blip of RFI here, 1380, very common frequency. You can always measure it more carefully by going to Live Spectrum, use the magnifying glass, zoom in, and there it is, 1381. There's another hint of a blip right here at 1400. That's also fairly typical. And then we have a big blip over here. That's the cold neutral hydrogen line. That's real astrophysical stuff, and we'll leave that in. But the others will cut out. So, back to Skynet. Now, this has been processed a number of times. If you want to process it yourself, you got to click here, create new Cartographer job, name it DR, so I know that it's my processing. Channel, both channels were good, so I'm going to sum them. Gain calibration, we're going to start with interpolated. Just to remind you what that is. At the beginning of every map right here, and at the end of every map right here, up in the receiver, we turn on a radio noisemaker. This is because the intensity coming out of the radio telescope, the voltage, can drift. Over short periods of time, only a few hours later, you can map the same region and get different results. But the noisemaker, it has to go through the same electronics. So if the map is coming out at a lower level, the radio noisemaker measurements, the beginning and end, will come out at a lower level. So Cartographer measures these and divides these into the data, normalizing them, putting everything in units of that noisemaker, noise source units. And that is stable over longer periods of time, days, quite often. Okay. So interpolated means we'll use both the beginning one and the end one. And this will normally work just fine, but there is a case where it leads to a problem. I'll come back to that in a little bit. Image coordinates, it's normally in equatorial. It's normally in the right ascension declination system, but we made this map in galactic coordinates. We're going to process the image in galactic coordinates. So for this particular project, we're going to make this map in galactic. Time delay is turned on. We're going to need that to correct that large time delay shift that we have in this data. And normally include raw images is turned on. I'm going to turn it off just to make it a little bit faster. You turn it off, it processes twice as fast. Though sometimes it's nice to have that so you can compare before all the corrections to after all the corrections. But just for this video, I'm going to turn it off. Skip frequencies, 2 have already been selected. You could add new ones by pressing that button, remove old ones by Xing it out. And we're cutting from 1380 to 1382. That's to get rid of the 1381 radio frequency interference transmission line. And also we're cutting at 1400, so 1399 to 1401. That will get rid of the interference in the map. But check your spectrum. You may have additional lines that you have to cut out, or these ones may not be a problem and you don't need to cut them out. Background subtraction, 6, that's good for sources, for making a map of the sources. If you have broader structures, they will get kind of wiped out by this. That's okay. We're focusing on the sources. And then here, I'd set that to bright target with airy rings. Many of these maps will have a bright target, one bright enough to have airy rings. If it has airy rings, we use different settings for everything else. Not all the maps will have one that bright, but you don't know ahead of time. So for the sake of uniformity and simplicity, we'll just process all of these as bright target with airy rings. That sets the rest of these. Just check everything. It all looks good. So I press the Let's Go button. Now, when we're making the tiny maps, like around the moon and Jupiter and calibration sources, they only take about 5 to 10 seconds to run if no one else is using the system. If other people are, it will slow it down. This is a larger map. It will take longer, be 30, 40 seconds. But we'll just wait for it. I'll just keep refreshing the page here. Oh, it's done already. Great. So I'm going to download it. And then we're not going to go straight into Afterglow this time. We're going to go into one of the Astromancer tools. So you go to astromancer.skynet.unc.edu, and it's the tool here at the bottom, Radio Source Finder. Select that and you'll be here. And I'll explain everything you can do in Radio Source Finder in an upcoming video. But right now, let's just check our image. So we're going to click here and we're going to load in that image we just made. And it looks good. Here's that really bright source that we saw in the preliminary data products, and everything else, we didn't see anything, but here you can. Okay, now more about this later, I do want to mention a pitfall. With these large maps, they should all be completed within a single data file. But sometimes, for reasons I don't fully understand yet, the data is split between multiple files. And when that happens, the map you receive back will be screwed up. Basically, Skynet retrieves just the first file. So if the whole map lives in one data file, you're good to go. But if it did happen to get split between two files, you'll encounter a problem. So to demonstrate that, here I have another map queued up. This is map 128. I'm going to create a new cartographer job, name it after myself so I can keep track. It's in galactic, interpolated. I'll turn off the raw so it goes a little bit faster. We have the skip frequencies that we want. Just double check this. Yep, there's some 1381 contamination, maybe a tiny hint at 1400. So I definitely want to clean spectrally. And all the rest is the same. So let's go. It will make this. Again, it may take 30, 40 seconds for a large map. Done. Gonna download it. I delete this one and load up that one. $128. There it is. Okay. If you see it really bright in the first row and then it just damps down, damps down, damps down, what happened is this was saved in two files. The second file wasn't sent over. And so, yes, we get the initial noise calibration, but the second one is in that second file that didn't get sent over. It was lost. And so radio cartographers just confused, trying to figure out how to correct this. So what you can do in this case is come back here and create a new cartographer job. And I'm just going to use the pre-gain calibration because since the data file was split in two and we've lost the second half, there is no post-gain calibration, just a pre. So I'm going to run it again just using the pre. Refreshing the page here. There, it's complete. Click on it, download it, and it should be mostly better now. This one. See, that fixed it up. Mostly. Still has the problem that the second half of the map is missing. So if you found yourself in that situation, you can do what I just did to salvage the first half of the map, but really you want to reobserve the field. Go back to Skynet here, and if it was your observation, there's a resubmit button, and you can just put it in again and try again to get it in a single file. And we'll work on that problem, and hopefully it will go away within the next year or two. Okay, that's it for this video.